Science is facts and drama is fiction. Never the twain shall meet. I suggest that science and drama are both a way of engaging into and of understanding the world. In fact, drama, I consider, may help students to engage into and understand science. Mentor of the expert can be a vessel to aid in that understanding. Another vessel on my screen is the T.E.B. Wahine, who founded within sight of our capital city, Wellington, in the aftermath of a tropical cyclone with the loss of 51 lives in 1968. That was an event that left a scar on our psyche. I spent many years working as a scientist, and prior to becoming a teacher, I visited a secondary school and noticed the students appeared to be disengaged from science. Not every child finds it easy to cross the borders between their life worlds and classroom science. Recent national and international studies have highlighted the fact that students are disengaging from science at school. This appears to start at about year 8, and are not choosing to pursue science-based careers. It's suggested that an interest in science and science careers needs to be established between the ages of 10 and 14. By international standards, most senior students in New Zealand are doing well, 7th in the OECD. However, international and national studies indicate that student achievement and engagement is dropping amongst our primary students. The Education Review Office, the New Zealand equivalent of Ofsted, is concerned about the wide variation in the quality of science teaching in years 5 to 8. Literature suggests that useful approaches to enhance the teaching and learning of science at middle school are ensuring activities are hands-on and teaching science concepts through real-life contexts, which are driven by the needs of the student. I suggest that Mentor of the Expert is a possible solution to engage students into science and science careers. Mentor of the Expert is a drama-based teaching approach that was designed and developed by the late Professor Dorothy Heathcote. In it, students are enrolled as experts within a fictional company or enterprise, and they carry out work on a fictional commission for a fictional client. Drama for learning strategies are used to deepen learning and explore multiple perspectives. Drama has been used in science before, but it's been mostly limited to exploring abstract physical phenomena, such as the student atoms, and role-play, like the evolution trial. There have been very few documented studies investigating the use of Mentor of the Expert to teach science. In this paper, I'll report on a study conducted in a New Zealand school investigating the use of Mentor of the Expert through a historical New Zealand event to teach the concepts of floating and sinking. I'll outline some of the drama strategies that were used in the unit, just the findings, and attempt to theorise using the lens of positioning theory. The school where I conducted my research is a Year 0 to 8 state school on the outskirts of a moderately sized city in New Zealand. The principal is supportive of learning through drama. Mentor of the Expert is being used regularly by some of the teachers in the school. For my intervention, I worked in a Year 7-8 class of 20 students and co-taught with the classroom teacher Jane twice a week for 90 minutes over the course of one term. The data collected included students' pre- and post-assessments, audio recordings of all classroom episodes, 3 interviews with the classroom teacher, and a post-intervention interview with 8 representative members of the class and the collection of classroom artifacts. Data was analysed statistically and thematically. I used positioning theory as an analytical lens. For this particular intervention, our company was named SEARS, Scientific Extreme Event Reconstructive Services. Our client was a governmental select committee looking at extreme events, and our commission was to re-examine the science behind the sinking of the Wahine and offer suggestions to avoid or mitigate future tragedies. One of the ways reputed to help students cross the borders between their life worlds and science is by working as scientists. However, working as a scientist in a school science laboratory is quite different to working in science professionally. In many of the instances where students work as scientists, they work as novices. This role would be out of keeping for working until the expert. Therefore, I need to devise a new way of maintaining the fiction of being an expert scientist and yet enable curricular content to be taught. Therefore, not only were students repositioned as expert scientists, the mode of teaching needed to be shifted to suit that new position. Instead of working from a traditional teaching approach that sees the student as a novice and teachers need to introduce them to the truth, I flipped the model on its head. I had to find ways to restructure the teaching so that the students could act as if they had the expert knowledge, but also allow them to explore, work on the linkages, and build up the knowledge to actuate that status. I'd like to share 3 examples of how we did that with you. In this instance, the concept of collective role or blanket role used was modified from a New Zealand process drama by Sharp. The aim was to find a way to give students conceptual knowledge without diminishing their expert status. Each child was given a strip of paper with a discrete science fact on it about meteorology and weather symbols. The children were asked to take on a collective role as Albert, an expert meteorologist. I took on a low-status role as one who does not know. I'd ask questions of Albert, and the child with the answer to my question would answer. Just to give you a demonstration. Our company, they're doing this commission for this client. It's looking into the sinking of the Wahine. And I don't really know much about that, and some of it involves weather. Do you mind if I ask you some questions, since you're such an expert on this? What is weather? And the child said, weather is the conditions that occur in the atmosphere. Oh, so it's all around us. You know, when I've been watching TV, I see this big letter H. Does that mean the day's going to be hot? And the child said, a high pressure area is indicated by the symbol H. The students were able to answer from the information contained on those strips of paper. This way of teaching paved the way for a lot of interaction and inquiry-led discussion. Some students were more confident than others in working in this manner. Lucy, a student, said, I ought to have it the way we did it. It's more exciting and includes everyone instead of just having paper. Jane, the teacher, noted, it's something that worked really well. I love the structure of it. I love the way it made sure that every child was on their game and they were listening out, just in case their sentence was called. Another strategy was to position the students as expert scientists working in research teams. The company received an archival box from the client. They gathered round the box and drew out the items one by one. A bag of marbles, a paper boat, a weather forecast. This looks like an experiment, but you can't read it. The children realised that the items were from the inquiry into the sinking of the Wahine, and some of the data was incomplete or damaged. When I asked them what they thought we should do, someone said, I think they might want us to do the paper boat experiment. Another child mentioned, they probably want us to see, to test it, how the boats sank. This role captured the imaginations of the students, making paper boats, using marbles and water, naturally added to the fun. They were starting to work as scientists, investigating and exploring the science and using scientific terms to ascertain why the Wahine capsized on the right side. This was the experiment that was mentioned the most when the students were writing their report. Our third approach also involved positioning the students as expert scientists. It was in this strategy that I consider we changed the way learning was positioned the most. Students were told that 3 people were applying for a vacancy at the company. They were shown 6 laboratory experiments and told the applicants had each been asked to carry out the experiments and provide an explanation for the results they obtained. The applicants had left their explanations in the form of laminated cards at the station. As valued members of the company, students were asked to assess the employees' statements, reproduce the experiment, and see which statement was the most accurate. Once the students had explored the science, they were asked to choose the potential employee whom they considered the best understanding of science and prepare a job interview, which they acted out. The students were able to physically show what they had learned and could link the experiment to the theory. For example, it happened something like this. Oh, hello, Julie. Come and take a seat. I've been very interested to see your results from the experiments. So can you tell me why objects float? And Julie said, the reasons why these objects floated was because the air trapped inside them lowered the overall density of the object, and the combined density was less dense than water. 5 out of the 6 groups chose Judy, who had comprehensively explained the science behind the experiments. They noted her answers were more complete and backed up with facts. When I spoke to the student about this activity and asked her whether having the answers in front helped her to learn science, she mentioned the little bits of paper helped because, maybe you might have thought it was something else, but it wasn't. Jane considered that using Mantle the Expert to teach science helped with engagement. She thought the key way we did that was through those interviews, and that is why the experiments were so valuable, because they alone wouldn't have consolidated that understanding. It appears that changing the configuration of the way science is taught in these 3 roles episodes helped the students to function as experts and gave them more agency in experimenting, discussing, and communicating their understandings about science. The varied approaches and curricular support helped consolidate the learning and contributed to the enjoyment. Tentative findings from the project are that Mantle the Expert supported purposeful learning. The Commission provided a reason to learn and a focus for teaching. As the teacher Jane mentioned regarding the interview investigations, it was so much more exciting because we had to do the experiment and find out which interviewee would be able to get the job. So there was a purpose, whereas before it was there's no purpose. Students also recognise this and note it gives us a purpose to come to school and a direction to go and put into practice what we've learned. This learning in science was demonstrated by speaking, writing and doing. As the unit progressed, I noticed the students were more able to use more complex scientific terminology and talk about the science behind the simple of the writing. When I examined their writing, I could clearly see the students were able to write in well as scientists using scientific vocabulary. We asked the students to not only give the reason for the way he was thinking, but to back it up with evidence, which they were able, most of them, to do. For example, a student noted, we can prove this theory because we did an experiment with paper boats and marbles. The marbles represent water. When you put them in the boat, it became denser and sank. Having a purpose made it easier to link the abstract theory with the experiment. What else, Josh? What difference? When writing the report, working in Mantle the Expert, rather than just normal research, he said, there was moments there that we remembered, because our body remembered, because we were doing it. This embodiment of learning, or physical remembering, may help students when they write and roll, and enhance their ability to link the theory to the experiments, to explain the phenomenon being investigated for the client, to fulfill the client. All students were assessed pre- and post-unit on a variety of questions related to weather science and floating and sinking. The questions in the assessment were modified from similar questions in a New Zealand-based assessment project known as NED, National Education Monitoring Project. The same test was given each time. There appears to have been considerable change in science knowledge in the assessment, with students changing from pre to post test was 74%. This change in science knowledge was confirmed by the understanding demonstrated in the reports and in the presentation to the client, who was represented by teacher in role. One way of theorising my findings is through the lens of positioning theory, in which players make meaning together about the world or worlds in which they live through discourse and how they position themselves or are positioned by others. Discourse, according to Harvey and Van Langenhove, has three components: positioning, speech acts, and storyline. In Mantle of the Expert, students are invited into a figured world, the company, with its history and values, in order to play within the Mantle of the Expert storyline, which is pre-planned to meet the curricular and social needs of the students. To build belief in my storyline, I showed the students artifacts which depicted the attributes of a company called Sears, which was Scientific Extreme Event Reconstructive Services. Jane and I then had to transition the students who held an abstract view of the company to being fully functioning members of our company, and this was achieved through careful speech acts and explicit positioning. We changed our pronoun usage from the company to a plural configuration and used collegial language. Students were invited to acquiesce to that positioning. Once they'd accepted the positioning, they started to self-position themselves as members of the company and her expert scientists. Jane and I were very pedantic about positioning the students as expert scientists with their corresponding rights, responsibilities and skills. We used role in the role to explore what a scientist is and does. We self-positioned ourselves as scientists by writing CVs. And once we'd strongly positioned and established the students as expert scientists, and they'd acquiesced to that positioning, there was not as much explicit positioning through the unit, and the positioning could be maintained in a more implicit manner. Explicit positioning and its subsequent acquiescence is important because it changes the power relationships between the teacher and the students and the curriculum. I suggest that Mantle of the Expert acts as a participant structure, similar to that discussed by Cornelius and Herrenkohl, in that it alters power relationships. Initially, the teacher occupies a supportive role and still holds most of the power. As belief is built and students grow into the expertise of their role and become more metacognitively aware of their learning, the power relationships are disrupted and the agency of the student in driving their learning is raised. By being framed as expert scientists and with the positioning supported in the mind, and through changing the way the curriculum is taught to maintain the fiction, students can function in a manner akin to real scientists, exploring and discussing the phenomena pertinent to the commission, and thus gain more agency in the learning of science. One of the students, Cameron, an expert in his own learning, had this pertinent comment to say regarding learning through Mantle of the Expert. It is to do with getting into role. In the beginning, you telling us, that's what you said, that we were told that we were experts. The mind believes you're an expert, so they say stuff like they are an expert. By the end of that, they were. It would appear that being positioned as this and acquiescing to that positioning, having a purpose to learn through the commission, and having the science reconfigured to support the standards of expert scientists can have both a positive effect on student agency in science and help students to link scientific theory with evidence. Therefore, I consider that Mantle of the Expert is a valuable tool to help students cross the borders into science. In addition, using drama in science can create a bridge between two curricular areas that seem at first glance to be widely separated.